It's been great to finally meet everybody in person. The last SC we did was 2019, and it's just the energy we've all missed. It's great to meet everyone, all the customers, all the vendors, and see what's going on in the community. At Azure, we focus a lot on high-performance computing and AI training. Our customers are really looking for training large models at scale. And if you look at AI training at scale, it is actually a high-performance computing job. This is where our partnership with NVIDIA allows us to have best-in-class GPUs, time to market, and we support that with back-end networks, the InfiniBand networks. And what this allows us to do is to train large models at scale.
We're super excited to be announcing that Azure is going to be deploying over 10,000 NVIDIA GPUs, both our current A100 and the next generation H100 GPUs in the Azure cloud. These are the same GPUs that NVIDIA is going to be using to develop our next generation AI software for the enterprise. We'll be using Azure, and our teams developing the AI software that the rest of the enterprises can be using for deploying AI. This means two great things. First, we're getting the best possible cloud infrastructure, the best GPUs and the best InfiniBand interconnected systems to develop AI at scale. And the enterprises will know that it'll be ready to run on Azure as soon as it's developed. So very excited to be partnering with Microsoft in this journey and help bring AI to all the enterprises around the world. Training large models is a hard task, and it requires enormous amounts of computation. It also requires the entire data center to work as one to train these giant models. Azure has taken some of our best GPUs, going from A100 and now the H100 GPU, including the new 400 gigabit NVR InfiniBand interconnect, to build basically supercomputers in the cloud, so that everyone can get access to the best possible GPU and AI technology out there to train their models, to do their research, and to make those discoveries that supercomputing is all about. With every generation of new GPU, we bring new technologies to both HPC and AI. The new H100 GPU actually has what we call Transformer Engine. This is a specifically designed hardware-software co-designed object that allows us to do those transformer-based layers inside of the world's largest neural networks. Neural networks like GPT-3, which was developed by OpenAI in conjunction, of course, in partnership with Microsoft and Azure. What the new 400 gigabit a second InfiniBand does is it really allows those GPUs and the systems within the data center to talk at the absolute fastest possible performance and with the lowest possible latency. That really increases the time to train, maximizes the computing resources that are available in the cloud, and reduces the time to solution to make these things even possible. So we're super excited to have 400 gigabit InfiniBand in Azure.
When you look at infrastructure, whether it's CPUs, GPUs, InfiniBand networks, what we offer to our customers is the full stack. We want to make sure from a platform point of view, the infrastructure is optimized for the job, the software stack that sits on it is optimized to get the best performance out of this infrastructure. So with our investments in NVIDIA, we showcase the best GPUs. We have InfiniBand, but then we have at Microsoft investments in software stack like DeepSpeed, where we are able to get the best performance for all of this infrastructure.
Technology is amazing, but if you don't give developers the tools or capabilities to use the technology, that's all it is. So NVIDIA has been investing increasingly in software. We actually have more software developers at this point than hardware developers. What we invest in is the software platform to help bring AI to the different vertical domains to make AI accessible to the developers and meet them where they are.
At Azure, our motto really is to do more with less. And what we mean by that is we don't want customers to actually move their workloads just from on-premise onto cloud. We actually want them to be able to optimize this. So you don't need to actually have all the storage data moved in, just move it into cloud. We want you to hydrate when you actually need it. We need you to be able to look at GPUs and pay for only when you need it. And by doing so, you can be really wise about how you are optimizing your applications, how you're optimizing your budget, and you're only paying for when you actually need compute power. By doing so, you're actually able to reduce and really be able to deliver much more efficiency with the dollars you have.
People don't know about all the different applications of AI, and really just discovering it now. People have now developed AIs to help forecast the weather by some of the world's largest supercomputers because they're adopting AI. Other applications of AI is in biology and drug discovery, looking at genomic sequences and understanding their behaviors and their chemical properties, as well as their effects as medicines, can be used, we can train AIs to understand not the language of chatbots or the internet, but actually the language of biology, of chemical compounds and their effects on diseases. Super excited to see what AI can do for drug discovery and help improve healthcare overall.
There are so many advances that are happening in language model, and then later these language models getting fine-tuned to do all sorts of scenarios. Like it's really hard for even me to keep up with everything that is these models are being used for. So I'm excited to see all the research that comes out of OpenAI. They're a big partner for us, but the downstream impact of what use cases become available because of the GPT-3 3.5 is just amazing. So in some way, what we make enable, the world is discovering more and more use cases out of it. And every day you learn like how these things are connected and the downstream impacts of it. It's very exciting.